Hi everyone. In this video, we're going to build off of what we know about linear relationships to talk about other functions. Then we'll be able to talk about transformations of those functions. So for right now, I want to tell you what a function is and talk about the notation. And then we're going to talk about some of the common functions that you'll be seeing a lot in your math career. As an Algebra 2 teacher, this is like all you do. So consider this a good preview. Then once we get through all this, we can do a fun project to close out the year. So first, what is a function? You may have heard this before, maybe back in earlier math grades, you saw function machines, something like this robot guy, maybe simpler, where something comes in and something comes out. So simply put, a function is just a relationship where everything you put in corresponds to one single output. Okay, so if you put one thing in, you should only get one thing out. I like to think about this like a vending machine, right? When you put $1 in the vending machine, the rule then is you press like F5. That's your rule. And when you press F5, that tells the machine to pop out Skittles. Okay, and if the function is working properly, you're only going to get Skittles from F5. You're not going to press F5 and then get Skittles, chips, and Cheez-Its, right? Then it wouldn't be working. You just want one single output for that F5 thing you put in. Okay, now in math, we're not talking about vending machines. Our rules in math are also called equations. So let's say our rule here is like x plus 4. Okay, then I'm going to put something in and get something out. So you can put something in for x, substitute something for x. It's an input is another word for it. Let's say my input is 5. Then the rule is you take whatever your input is, we call that x as a placeholder, and you add 4. So if our input is 5, it'd be 5 plus 4, which is 9. Okay, and we could keep doing this, and you should only get one single output. So I could do 3, 3 plus 4 is 7, so on and so forth. But you should only get one output. You should only get 7 when you plug in 3, not multiple things. Okay, that's what a function is. We'll talk about this a lot more later, but that's just a preview for now. Okay, just to recognize some notation, normally when you see a rule like x plus 4, you would see it as y equals x plus 4. Okay, that's just, the notation we've looked at up to this point. Functions have their own notation, but it means the exact same thing. Okay, when you see a function, you're usually going to see something like this. The way you say that is f of x. Oops, f of x. That's how you pronounce that, f parentheses x, f of x. Okay, it means the exact same thing as y equals x plus 4, but this is function notation. Function. So anytime you see this notation, you'll know that thing is a function. Now, the only difference between these things is instead of saying y, you're saying f of x. Okay, f is just the name of the function. So it's like the name of the vending machine is f, or the name of this robot is f. It's just a name. That's all it means. And then whatever's in parentheses here is your input. So normally in functions in math, we use x as the input, right? So I use x here. I plugged in 3, 4x. Whatever you put in parentheses here is the input. So it doesn't have to be f of x. It could also be g of x. All that means is the function's name is g, and the input is the variable x. Okay, or you could say, we usually use a letter, but it doesn't have to be. I could use smiley face of x. That means the function's name is smiley face and the input is x. Or you could say like f of 4, which means the function's name is f and you're plugging 4 into the function. So if my function again is f of x equals x plus 4, well, you replace the x with 4. That means the new input is 4. So you're going to plug 4 in wherever you see x. And then you have the equation 4 plus 4, which is now 8. Okay, or you could do f of 10. 10 is now your x. 10 plus 4 equals 14. Okay, so again, this piece here is just your input, and this piece is your name. It means the exact same thing as this notation. It's just like another way of saying it, and we know a little bit more information when we use f of x instead of just y. So that's some notation you may see as we go through, but the main point of this video is to talk about parent functions and the different types of functions you'll see, and then what do their graphs look like. So a parent function is the simplest function from that family. So we all know lines. I'm going to use lines as an example. We know lines as y equals mx plus b. So that could be like 3x plus 1. We also know them in point slope form. So it could be like y minus 7 equals your slope times x plus 1. I don't know, I'm just making these up. Okay, these are functions. They're equations, they're linear, but they're not the simplest from that family of linear functions. Okay, the simplest would be if our slope was just 1 and our y-intercept was 0, and we had the equation y equals x. Or if our point was just 0, 0, right, that would no longer be there, and our slope was just a 1, we'd also have the equation y equals x. So this is the simplest linear function you could have, y equals x. So that's called the parent function. Basically, it's like the plain function without any numbers being added, subtracted, multiplied, or divided to it. Okay, we should be familiar with a parabola more or less, right? A parabola is like y equals x squared. That's the parent function for a parabola, okay, because it's the simplest. You don't have anything added, subtracted, multiplied, or divided. Okay, if you had y equals 2x squared, that would not be the parent function because it has the 2 there in front of it. So it's not the simplest function. Okay. So we've talked a lot about linear functions. So you could have y equals x. It means the exact same thing as f of x equals x. F of x is just another way of saying y equals. Okay. And the parent function then has no numbers. It's just the simplest one, like y equals x, like I talked about above. And the graph would look like this. Okay, so the rule y equals x means whatever your y value is, it has to equal the x value. So that's why you get this line here. If I have x is 1, then my y also has to be 1. If x is 3, y also has to equal 3. If x is negative 2, y also has to equal negative 2. That's why the x and y coordinates are the same, and you get just this line going through the origin. Okay, so this is the parent function of a linear graph. And as a reminder, we always write our points. You'll see throughout this video, x goes first, y goes second. So it's your x coordinate, y coordinate. And since the rule says y equals x, right, the x coordinate is equal to the y coordinate. They're all the same. So we've talked about linear functions. I'm not going to spend a lot of time on that, but that is the parent linear function. Okay, then you could transform that function. You can move it up and you get this line. You could make the slope negative and steep and you get this line. Okay, those are all in the family of linear functions, but the parent function is y equals x, and it looks like this. Okay, quadratic functions, the next ones I want to mention. So that's y equals x squared. Quadratic is a squared x value. Okay, squared meaning to the second power, it's the exponent. And that looks like this shape here. Quadratic function is always a parabola in shape. And a parabola is just this U shape. I know it stops here, but in theory, this goes on forever. You just can't see all the way up there. Okay, what a square does is it's repeated multiplication. So y equals x squared means y equals x times x, or x 2 times. Okay, so let's say, again, your points are written as x comma y. And let's say you have the point 2, 4. 2 is your x, 4 is your y. The reason you get that point is because you're squaring your x value. So it's x squared is 2 squared, which is equal to 2 times 2, which is 4. Okay, same thing with 3, 9, right? 3 is your x value, so 3 squared equals 9. Okay, or you can do that with the negative numbers, and that's why you get this symmetrical shape, right? We're symmetrical over the origin when I have my parent function quadratic. Right, it's symmetrical of the origin. So this point would lay on top of this point if you folded it over the, again, this is the y-axis. And just for fun, this is the x-axis. Okay, so if I take my x is 3, my y would then be 9. I'm sorry, negative 3. Because negative 3 squared is equal to negative 3 times negative 3. 3 times 3 is 9, and a negative times a negative is a positive. So you'll get that when you plug in negative 3, you get positive 9. So this is what all parent functions for quadratics look like. Again, the parent function of a quadratic is y equals x squared. It's the simplest quadratic. There's nothing being added, subtracted, multiplied, or divided. It's just y equals x squared. You're going to get this U shape. It's good for like a smile. Okay, absolute value function looks like a V here. So it's kind of like a parabola, but not curvy. Okay, an absolute value, hopefully you've seen before, is this notation here. So I'm going to write this bigger. So you can write y equals absolute value of x, or, as we learned before, you can do f of x. Means the same thing. And these bars here denote absolute value. All absolute value does is it measures the distance from 0 on a number line. And distance is always positive. So if I take the absolute value of like -5, the distance from 5 on a number line would be 5 units away. Or if I take the absolute value of, let's say, x is -3, the absolute value would be the distance from 0 would be +3. So this y, this is x is 3, then my corresponding y value would be +3. Or if I plug in 1 for x, well, the distance from 0 to 1 is just 1 unit away. So the absolute value of 1 is just 1. Or you can think of it this way, absolute value makes any number you plug in positive. Okay, so that's why you're only getting things above, up here, positive y values, or above the x-axis. Okay, so the parent function of an absolute value function doesn't have anything subtracted, added, multiplied, divided, because it's the simplest function, right? We could transform one of these absolute value functions. Let's say I added 5 to it. That's in the family of absolute value functions, but it's not the parent one because it's not the simplest. But all absolute value functions will look like this, where they're v. They may just be like shifted up, down, left, right. They might be skinnier, they might be smaller, etc., but they're all a v. That's what an absolute value function looks like. Okay, maybe you've seen an exponential function before, possibly in middle school math. It's where you have that rapid growth like you see here. You might have seen a lot of this in the news lately with the coronavirus, where our numbers are growing exponentially as more people get infected. So this is an exponential function of base 2. You can write it as y equals 2 to the x, or you can write it as f of x equals 2 to the x. And what that means is x is going to be what's changing. So your exponent is changing. So if x is 1, you'd have 2 to the first, which is just 2. So when x is 1, y is 2. Or if you plug in, let's say, 3 for x, it'd be 2 to the third, because that exponent is changing, which is just 2 multiplied 3 times. And 2 times 2 is 4, times 2 is 8. So when x is 3, y is 8. So you're going to get that, like, it grows really, really fast, because the bigger the exponent is, the bigger the number is going to come out. Okay, so that's an exponential function. Again, this is a parent function, but all exponential functions will have that rapid growth structure. It could shift to be over here or over here, but it's still exponential in structure. But the parent function is, you know, the base function where you don't have anything like added to it, like +1. Okay. So that's an exponential function. More functions, you could have a square root function. So square root of x looks something like this. My teacher called it a shooting star when I was in class back in the day. I'm not going to go through this too much, but remember, square root kind of undoes a square. And you could have other roots, but we're talking about a square root. So let's say x is 9. Well, then your y value would be the square root of x, which is the square root of 9, which is 3. So when x is 9, y is 3. If x is 4, the square root of that is 2. When x is 1, the square root of that is 1, or it goes to the origin, so the square root of 0 is 0, and you get this shooting star type of structure. And again, I'm just trying to show you what all these different functions look like, because if you're familiar with them, it's going to make, studying them in detail a little bit easier. And also, we can use some of these in our project later. This is a polynomial function. It's a cubic function, so it's kind of like y equals x squared. This is the parent function, though, for x cubed instead of x squared. So instead of multiplying your x value 2 times, y equals x cubed means x 3 times, x times x times x. So you get this structure here, right? So if x is 2, 2 times 2 times 2 is 8. If x is -2, -2 times -2 times -2 is -8. All right, so if this is my x and this is my y, -2 times -2 times -2 is -8. So you get this structure here. And basically, the moral of the story is for any function, you can plug in values for your x to find the corresponding y, or plug in values for y to find your corresponding x. And depending on the rule, it's going to look a little bit different. So linear looks different than a parabola. So my goal for this video is to have you recognize these functions, and we'll do more with them later. Bye-bye.